Okay. First of all, thank you, Sergio, and thank you for all your team for the organization of this congress. Today, I would like to share with you some key results about my postdoc at the University of Liège in Belgium, in collaboration with the University of Patras in Greece. So today, I would like to introduce the modern RION STRAIT in Greece with a special focus on the interplay between the tidal currents and the internal tide. So let's go. I would like to start with a quick reminder of what Sergio did, but we all know what he did. So in many straits are dominated by tidal currents. So this is a tidal strait, and he developed this tidal strait deposition model. So Sergio is the father of this tidal strait deposition model. In the proximal straits, in the strait center area, an erosional area, and on each side of this erosional area, we can find the deposition of 3D and 2D tidal gems. Additionally, we can observe some internal waves, like you can see on this example of the Strait of Gibraltar, when the Mediterranean waters try to get out of the strait and are blocked by the Atlantic water, and at the boundary between the Mediterranean water and the Atlantic water, the energy increases and is released with this set of internal waves. The internal waves can travel with very high velocity, with greater than 2 meters per second, and with a very high amplitude, greater than 100 meters, and you can see the surface signature of these internal waves inside the Strait of Gibraltar. More recently, Hubert and his collaborators and colleagues have shown that associated with this train of internal waves, there is some internal hydraulic jump near the seal, near the caraminal seal, and also can be almost instabilities. So now let's go to the RION Strait. So the RION Strait is not far away from here. So it is located in Greece, and it is connecting the Ionian Sea here on the left with the deep scoring Gulf with bathymetry up to 900 meters depth. In this area, the Patras Gulf is a very shallow area, no more than 100 meters depth. So this is an asymmetric strait. So the modern RION Strait looks like this. This is only a 2.5 kilometer length strait, but until this study we have any idea about the water circulation or the strait morphology of the RION Strait. So in a few words, the geological context can be summed up in two areas, as you have recognized the famous Coral Reef, which is a very young and very active reef with a very deep basin, more than 900 meters. And on the western part, you can observe the Patras Gulf, which is overfilled by 3 kilometers of sediment, and which is a very shallow area, no more than 100 meters. So this very shallow area and the sea and the system of the strait here is at the boundary between the Coral Reef and the Patras Basin, so at the frontier between the two basins. And this area is controlling the environment of the deep current rift, as you can see on this on this profile. This shallow area, depending on the sea level, controls the lake clustering environment or the marine environment, and the last transgression has been recorded in the Marion-Dufresne piston core by the occurrence of microbialites, so during the Holocene transgression between from lake to marine condition. So we conduct a new survey with the Patras University, with seismic profile, high resolution bathymetry with multi-beam, and also we had ADCP, so an acoustic Doppler current profile, to have an idea of the current of the area. Moreover, we combine this survey with satellite data data to extend the time series and the extent of the result. So the first question, and it was the main focus at the beginning, was to image the fault escarpment at the surface. As you can see, and despite an intense seismicity and a very fast opening rate of the rift, there is no significant fault escarpment at the surface. So the normal faults and strike slip faults are mostly identified thanks to the seismic data. Another point that you can see on this bathymetric map is that I failed to find some dunes. I don't know if you see some dunes, and we can go in detail. So where are the dunes? If I detail some depositional, some morphology of this strait, in the strait center where the construction is maximum, you can observe this plateau, which is a very broad plateau, and this plateau is also cut by a moat or tidal channel. I don't know if the terminology is correct. And on each side, in the intermediate area, you can observe some pull and crest morphology, which are deep and 100 meters of circular erosion limited by crest here on each side of this strait. Moreover, on the northwest part, we can find some step terraces cut by fault, normal fault, and in the deeper part, towards the current group, we can observe some spits and scoring. I am speaking about scoring because I have this very nice high resolution seismic profile here in the middle of the deepest part towards the current growth, where you can see very large spool and field with long wavelengths and low amplitude, so which is characteristic of supercritical currents and erosional features. If we are looking at the cross-section, a north-south cross-section, you can see that in the middle, in the deeper part, we are still in erosion, and the sediment deposits are located here on the slope, and they are plastered on the slope as a drift, so as a common bottom current system. So this is maybe the most interesting of these talks. This is the analysis of the ADCP tidal currents. So here you can see the direction of the current depending on the tide, but only for the strait area. We are not speaking about what's happened in the deepest part and near the current gulf. So in the strait area, the ebb tide is dominated here in blue by northwest current, northeast current, so they are inflowing the current gulf. And at the opposite, during the rising tide, we have some southwest currents which are outflowing the Gulf of Currents. So during ebb tide, you can see on this profile that the currents are inflowing the Gulf of Currents by surface currents. At the same time, in the deepest part, you have very high velocity currents here in red. Okay, thanks. Which try to get out by bottom current. During rising tide, you can see that you have a massive outflow by bottom current from the Gulf of Currents, which are outflowing the straits. So the maximum velocity are located in the deepest part of the Gulf of Corinth, near the Gulf of Corinth, and not in the strait area. In the strait area, we can see surface waves that are indicated internal wave, as well as some upwelling from the Gulf of Corinth. So to be quick, we have an astronomical Mediterranean tide of 12 hours of period, and we have some internal tide of 6 hours of period. So how does it work? I don't have the time to repeat myself, and I don't know how many time I can speak. Yes, okay. So I will move on this stratigraphy. As you can see, there is a major unconformity here at the base, so this is an aerial unconformity. Then you have isopaque deposit, and then you have a second unconformity, marine one, with the occurrence of marine currents. If we populate this concept and the horizon, the unconformity through west to the east, through the strait, we obtain this kind of thickness map. And this thickness map can quantify here for the marine stage the erosion of the strait. Inside the black line, this is the bypass area. Despite the red line are highlighting the erosional area. So the erosional area corresponds to the pull and crest area, and the strait center is only a bypass area due to the presence of living corals that are protecting the axial strait. So this is my conclusion for today. This strait is dominated by erosion and dominated by internal tides from the deep Gulf of Corinth. And yes, there is an erosion on this east-west pathway, and the deposition of the sediments occur on the slope as drift, and we have no evidence of dunes inside this strait. Thank you for your attention.
Other questions? So while they think, can you come back to the interaction between the surface tides and the internal tides, since you guys had to rush through that, but it's really interesting.
Okay, here for example, I think it's a good example. This is some data, so this is not a model, this is basic data without processing. So here this is the velocity of the current, and here you have the direction of the current. So you have two things. You have the incoming flow by tidal current. This incoming flow is warm water, because you have to cross all the shallow area, so you have some warm water going inside the Gulf of Corinth. And at the same time, you have cold water by the internal tide, which try to get out, but they don't cross the strait at this point. This incoming of warm water are enhancing the contrast between the cold water, deep cold water, and the surface warm water. So during the rising tide, here, the internal tide has more energy and can go out and flow over the strait. So the engine is the tide, the astronomical tide, which are exciting the internal tide of the Gulf of Corinth. I don't know if it's clear or not.
Yes, thank you. Yes.
Hi, thank you for your talk. Just a curiosity. Did you have control on the lithology of the deposit that are accumulated
Yes.
in the strait? Because we had in the previous talk that it seems, according to that talk, carbonate dominated. But for example, the Caranzaro Strait is caustic dominated, so I don't think it's correct what
Yes.
stated before. So I would like to hear from you from that example as well. Thank you.
Yes. Thank you for this transition. Yes, this plateau is made of pebble and boulder, and this is encrusted by living corals, so this is protected. Here, on each side, you have this pull and crest, and on the tip of the pull and crest, you can find some pebbles, and these pull and crests are dug like a fluvial pothole by the bottom rivers. If we move now towards the east, so inside the Gulf of Corinth, we try to see if we have some dunes and what kind of lithology. So we have some piston core, here some data from the piston core. The strait is here. So we say, okay, maybe all this area is an erosional area, and here it is a depositional area. So we have some lithology. As you can see, this is a very fine-grained lithology with the tree facies association by settling, gravity-driven, with fine sand, and also a lot of reworked facies association with a lot of erosion on surfaces, as you can see. But this is very rapidly decreasing. Yeah, and the question is, where is the sand? Yeah, I don't know.
I think we should move on, so thank you.
Yeah, thank you.
The last talk of this session before the break is by Valentina Rossi, and she's going to compare the